we learned about two set, which is hash set and the tree set. I think the only difference between the two is one is sorted and the other one is not. But I couldn't remember. I think it's the hash set is the not sorted one. So the tree, I think how it works is exactly the same, but tree, when you add some values to the tree set, it will automatically sort it in ascending order. I think if it is string, you sort in alphabetical order. If it is numbers, it will sort it into numbers, etc. So what I remember that the teacher told me was which one is better. He said that the hash set is better because it is unsorted. Thus it use less resources. I don't know what resources, I mean the CPU. The hash set just puts everything inside. You just don't do the sorting. However, the tree set, it requires extra resources to do the sorting. So it is essentially the same as the list, but the main difference is, as you can see here. Yeah, nope. Alright, you can see here it is unordered values without indexing, so everything just get into it. No one cares. It's like just put it in there and just forget about it. So it does not allow duplicate values, as you can see here. If you do put a duplicate value, it will just take the second one. I mean, it doesn't matter. Accessible using for each or iterator and while loop. It doesn't cannot be accessed with just the normal loop, which is like the for I equal to 0, then I is lower than 10 and I plus plus. That doesn't work because it doesn't have indexing. So next, yeah, as you can see, it is sorted in ascending order. It's not a duplicate. This is tree set. The one which has set accessible is the same, and then you can just use this is just cut modify max. Alright, so let me show the codes. This is nothing. This is just the print. This is just essentially how you add stuff, the same as list, and it's how you remove. It's the same. What's this? This is wrong. It's wrong code. It's my attempt. Remove one. Do this first. So if I run this, you see the original is 4 1 2 3. This is hash, right? So hash it is not sorted. So for example, if I show you the tree one, the tree set. What's this? Yeah. So for example, this is a tree set, and so as you can see, the first one is not sorted. It's just random. It's 4 1 2 3 5. I don't know what's happening. But if inside a tree set, you can see it's T first, and then O, and then F. This descending order. Why is that? Maybe it is because of this. I think it's because of this. So for example, if I just change it to 0 and 1, it's supposed to sort it in ascending order. Yes, F, O, and T. Right? It's the same. You remove 5 and essentially how to remove remove the 5, not remove, you cannot remove like 4, doesn't work because there's no index. Right, so for example, if I just run this, see there's nothing happening. Windows 1 2 3 4, supposedly if this is array list, this is supposed to be removed, but nope, it doesn't, because there's no index. Brings up to 5. Alright, this is my failed attempts to remove 1. So the way you remove 1 is this. This is the right way. You use iterator. You just pass the value into the iterator, and the iterator will then iterate inside the set, and that's how you that's how you, it's kind of giving like index somehow, but it's not. As you can see, you remove 1. There's no 1 here. There is 1, but there's no time here. It works. It doesn't work like the traditional way. This is like the array list way. Oh my god, what am I doing? So this is my attempt. It has no compilation error. I don't know. It doesn't show any errors, but when I click it, there's an error. See, because you just can't. There's no index. There's no way you can just iterate into the list of the sets. Oh my god, this is so confusing. But that's how you iterate. You use iterator, and then this is the boring stuff. Is it empty? Yada yada. No one cares. Let's move on. It's essentially the same, like exactly the same, but it is sorted. So let's just move on from that. Doesn't need it. So map, I don't remember why is it. What makes it different? Let's refer to the slides. Like it is an unordered sets of key and value. It is indexed by key. Yes, this is some kind of a hybrid between array list and sets, right? Because sets is unordered with no index, and array list is indexed. So like the index, if you add 1 2 3 4 5, the index will start from 0 1 2 3. So what makes hash map special is you can use the key any kind of data type you want. For example, in this case we use integers. If you want to use strings as the key, you can also use that. You want to use float. So the key is what makes it is kind of indexed by the key. If you use integer, it's kind of same, but if you use string, I don't know how it will work, but it will work. So essentially the hybrid. So this is how you declare it, and this is how you add it. It doesn't use add, it use put. So put 1 with key 1. Oh, another thing, the key has to be unique. You cannot use the same key. I mean, if you use the same key, example this one, you just replace it. I think it's this one. What's this? I'm just gonna comment. Okay, you can see 1 into 1, 2 into 2, 2 into 3, 4 into 4, and 5 into the 4. It's same key. So the result, you see, there are only 4 elements, and the 4 does not exist because it is replaced by 5. Alright, so map get 4. This is get the key 4, which is 5. Yes, 5. If you can put this if you can see before it, put if absent. Right, so the 4 will be there because the 5, this means that put this value into this key, which is 4, in 4 it's not used. So but in this case 4 is used, so yeah, 4, that's why 4 is there. And this 4 appears because of this map gets the key. Then this is how I print contains key. This is like if the key, if you want to make sure, like if T4, is there anything there? Is it true? Is there anything on key 5? No, false. This is like is there a value 4? No, yes, 4. There's value 5? No, false. That's why. So pretty simple. Straight to the point. Moving on. Boring. This is how you remove. You can remove just by key. For example, oh no, I need to print. So you can see. Okay. You see it remove. Oh yeah, remove the position at the key 4. So that's why there's no 4 here. Now, even though this one says remove key 3, key 3 is still there because this is like remove a value if the value is at key 3 and the value is 3. Like it is like an AND statement. You must satisfy both before you remove it. So that is useful in some ways. Let's see in future. I smell something weird. It's okay. So this is how you replace. So now the key 3 is contain value 2. Why do I use the example? I just use like apple or something. Never mind. I don't want to talk this one first. I just want to talk about this. So this is the original one. C3 has value 2. Now you want to replace with 3 using 3. So now it is replaced. So if that's how, but that's another way. This is the same as this one, like the remove one. It's like the end. I want to replace a value at key 2 if the value is 20, which is like the older value, and I want to replace it with this. Obviously there's no value that's 20, so I'm just gonna ignore it. For example, if I want to do it, this is this. For example, here 2. Now it will work. See 22. Alright, and then I don't know what this does. Can't remember. I think it's like iterating because there's no index, I guess. Because it is not indexed particularly. I don't know. I'm sorry, I can't remember about this one. Then that's for the collect data, the data structure part.